Right, we're going to have to do something we don't normally do, and that I've still got that DNT B40 base station in major surgery. Mr. Chippy's not been available very much, and it's his job to put that together. So we're going to have to carry on, otherwise it'll have been 28 days with one set on the bench. So, Midland 2001, and uses the Maxon chassis. This one's come in a box, not bad for 40 years old. It's got the destruction book, which has the service information in. We've already got a scan of that. We'll go and get a duster for some extra protection, seeing as this is in a plastic bag. Right, so pretty immaculate for the age. February 82, so it's the second batch. I'll put the soldering iron on because chances are I'm going to leave that on the plastic until we do the on the air test. It even smells of new radio. It's actually still the way they bear the wires and leave the insulation on at the end. So we'll try and retain that. I'm going to start this off at 9 volts. Because it's the age it is and not being used. Well, I'm assuming it's not being used. That's not a sealed box. Let's power it up. That's fine. Put it to 13.8. It's on channel 20. Plug the mic in. Plug the test instrument speaker and the PA speaker in. Testing 1 2, testing 1 2 1 2. That's fine on PA. So we'll unplug the PA speaker and we'll get a form to fill in. Right, let's move on to some technical stuff. Switch picture in picture on. And let's see what it's transmitting at. I'm on the 3 watt scale and it's doing just about 3 watts. So we'll put down 3 watts. These don't have low power, which was a bit naughty because it was a requirement. 2.9 watts on channel 40. channel 1. For what it's worth, we'll do deviation, but we'll do that more accurately on the other test set. Wow! Actually, that's 2.2 showing on there. We won't be doing VCO. And the transmit current, let's go to channel 20. 904 milliamps. Let's go over to frequency. We only had the test set on 10 minutes, so it won't be that accurate. So it's not far off enough to be actually off frequency, and it's within tolerance. Add 10 to that for when the machine warms up. So we'll put that into the signal generator. There we go, exactly the same, so that it's fair. Put the cyanide meter on. Turn the squelch down. And we have got 0.52 microvolts, which is very good. It helps if I show you the other meter. Helps if the poltergeist hasn't moved the camera. And for 10 dB, 0.47. For 20, 0.94. Full squelch. Bit high. It is 3 millivolts. And threshold .5. So when we key up, the signal meter says 4, and the S meter at 100 microvolts says 6. So let's see if we can adjust that. What is 9? And 9 on this radio is 290 microvolts. So some of these it's adjustable, some of them it isn't. If it isn't, we don't modify the set, and that's company policy. Right, so that's working nicely. We'll drop the screwdriver on my remote control. Why has this screw suddenly gone so tight? I don't know. I must not lose these screws, as we don't seem to be able to get silver ones. Right, well, I'll put it on frequency. It's now 20 minutes, so we won't be far off from the half hour the test set needs to be on for a guaranteed stability. It's going to transmit. No, we won't. We'll go into the frequency display. Key up. I'll check this in a couple of hours later. Good. Staying on channel 20 and going into the main meter, we'll keep it on the 3 watt scale till we go beyond full scale deflection. Little tiny bit there. Now we're beyond full scale deflection. See, it's not just 2023 new sets that come out of the box doing not 3 watts, sorry, not 4 watts. It was just the same then, because the problem has always been getting through customs, because our customs officials will test probably 1 or 2 samples of radio, make sure they're not doing anything they shouldn't be. Now they actually have you adjust those other, talk about others, where's my other glasses? Oh, they're on the floor being trodden on. I really don't like the way this is done. So, looking at the transmitter, 11 and 15. Mainly placement to make sure he's exactly in the right position. Next 3.2 watts. Oh well, it's up from 3. Right. So 3.2 and on channel 40. It's 3 and channel 1 3.2. So we've now got the transmit power up. We've now got the current consumption up at 966 milliamps. I'll do deviation now. I'll just do that with the test set behind me. So it read right on this one. So will it read right on the other one? Wow. Yes, it does. Right, I'll switch that off. So although it's a new set, it's been set up by somebody because the deviation wouldn't have come out of the factory as high as that. Right, let's get on with the receiver. So now we're on frequency, we're going to have to alter the signal generator so that that's now where we now are. We'll end up with a lopsided radio. That'll do. So the first thing we're going to do with S9 on the signal generator is the detector. So we'll go over to the oscilloscope. I've said a million times, it's just above the, it's just connected across the speaker. Miles out. Absolutely miles out. That'll make a huge difference. It might make the set less sensitive, but at least it won't be garbled. Right, we'll go over to the cyanide meter. And we'll answer the door. Right, we'll try again. So we're going to set the cyanide meter. We're going to set the signal generator. The cyanide meter gives us a meaningful response. Don't think we'll go lower than that. And that's come up a little bit. That's come up a little bit. So is that. Okay, so see if we get a reading anywhere near what we had before. For 12 dB, we now have 0.59. Despite doing the detector, it's not made it that much deaf. So you can often have if I twiddled the detector and showed you the cyanide meter, you'd probably find we get more sensitivity, but of course you can't resolve the audio like that. So for 10 dB, 0.57, and for 20, 1 microvolt. Now this should have sorted the squelch out, hopefully. Full squelch. No, it hasn't. 100 microvolts. We need to adjust the squelch. I seem to recall that it's that one. I might be wrong. And well, I'll put my tool down somewhere. Well, if it is, it isn't that one. Right. That is RV. That's 122. That's RV 101. Yeah, it is. It is. Or is it the? Or is that the? Yes, it definitely is. There's the squelch control. There's the preset squelch. So it's still not as sensitive as I would like it on squelch. But that's the way it is. So we'll twiddle it to what we can get. So that's the most sensitive. Oh, it's very close, to be honest. It is 160 microvolts. That's certainly better than 3 millivolts. So there's no rule about this. It's me who likes them to be 100 microvolts, which is S9 equivalent. It needs a bit more than S9. But what you don't want is a squelch that never ever opens, regardless of the signal. Oh, look, my squelch is so hard. Threshold is now what? 0.44 microvolts. Good. Now we need to look at S9 on the meter if it's adjustable. So it's reading about signal 6. Now sometimes there's a preset on the back of the meter, but there isn't on this one. There is a preset 102, and I think when that's fitted, that is the. It says 105 here. Is it me who can't read? It says it definitely says RV 102 there, but it definitely says RV 105 there. So once again, we'll have a look at the circuit diagram. Could have got the notes out, but there you go. It's probably longer to go to the filing cabinet than it is to sort this out. So, if we find the meter, if we find a meter there, the 103 preset, it just looks like there's the one preset. It says 103. But 103 is our transmit one, which I'll just do. And then I think that this just isn't on the radar because it's not in the circuit. It's the old, we strive to continue to improve our products. Yes, it is. So on this set, it's the meter preset for receive. Now we haven't had to touch deviation. The deviation is the preset there. So squelch, deviation, RF meter, and receive meter in this set's case. Now on sets with low power, with the same chassis, that can be the low power preset. Good, well, I think that's everything, isn't it? So now, I've still got that to read 4, even though the set's doing 3.2. That's now correct. Well, it's just a bit of a tune-up, wasn't it, that? Tin those. Yellow to the back. See if Mr. Chippy's available for a scratchy corner test later on today. The trouble is, if you spend 1 month on one set, you know, you end up with a backlog of repairs. And although we don't, we kind of have a 28-day turnaround. I do like to do them quicker than that, and then it stops me doing the sets in between that I want to do. I want to show you the CB240 chassis used in the Harvard 400M. We've got a scrap set to kind of see if we can resurrect, you know, things like that. I like resurrecting scrap sets. Not for customers, for me. They're self-tappers, these. I didn't realise that. So that one we struggled with. It just looks a more corroded screw, and I think that's why we were struggling. How's that happened? Right, we'll put it on the aerial now instead of the test set. I'll tell you what, we'll put it on the extension speaker, which is an SW711, as we keep mentioning. 190, Roger. Oh, we've got farmers on 9, haven't we, around here? We just missed them talking. 190, Roger. Right, we'll leave it on 9 in the hope that Farmer says something, but won't hold my breath. Yeah, we are rather immaculate Midland 2001. I better unwrap the microphone for later on when we do an on-the-air test. And then we'll be back to that DNT when Mr. C feels like he's able to fit that in. So thanks for watching Midland 2001 from 1982.